Anyone?
Okay, so let me show the last year paper again, right? So basically this is the paper. I think this year is 1.5 hours, right? Is it right? 1.5 hours, right? And again, you need to choose 3 questions, right? No to 4. No to 4 questions. Okay. And there are 2 questions from my part and 2 questions from one class part, right? So you are free to choose any 3, right? And some students ask me about the formulas, right? So if you look at the last year paper, you only have these 4 formulas. This year we have some new formulas, right? So these are let me show you. These are the new formulas you are going to see in the exam, right? Because the last part, which is the curve fitting part, right, is a new material this year, right? That's why you cannot find any questions in the past year paper, right? So you know what I mean, right? So yeah. So the curve fitting part is a new material, right? So you need to pay extra attention to that, right? And these are the formulas you will see. These are the additional formulas you will see in the exam paper. It's given. They are given, right? Okay. Okay. Let me go through some of the questions for the last year paper, right? So let's say, so question 3, right? Yeah. Okay, so for question 3, the part A, right? Part A. Part A, so you are given the result in table 3.1, right? So which is here. So you have how many data? 1, 2, 3, 4, 5, 6, 7, right? You have 7 data, right? So the question asks you, the final result in the table 3.1 is too low, right? Which is 3.85. It's too low, right? If you compare to the rest of the data, right? So the question asks you determine if you need to reject this data point. Right? This is only 2 points. Right? Because this question, the average value and standard deviation is given. And you don't need to calculate. Okay, so how can we do this kind of question? Right? So we need to use what kind of criteria? Huh? What kind of criteria? Yeah, see something. Cover that. Okay. So, what is the Troutman criteria tells you? So this is question 3. One. So for the Troutman criteria, first you need to find out what is the probability you need to use. You need to use for the rejection, right? So what is the probability? Which is 1 minus 1 over 2n, right? Yeah. So for this case, what is n? 7, right? N is the number of data points, right? Which is 7. 1 minus 2 over, 1 over 2 times 7. So this one gives you 0.9286. So once you have this probability, you need to find out the corresponding tau. Right? So which table you need to use? Normal distribution or t-distribution or what? Huh? Normal or t. So because in the exam paper, right, you are given both tables, right? Gaussian distribution and also the t-distribution, right? Yeah, you have two, right? Which one you need to use? Gaussian, right? Yeah, this one you need to be very clear. Permanent material, you need to use Gaussian. So for the Gaussian distribution, you 0.9286, right? So you need to find out the corresponding tau. 0.9286, right? Will be somewhere here, right? So it's about 1.8, 1.81, right? Okay, it doesn't matter 1.8 or 1.81. Okay. Then next, how do you determine whether you can reject or keep the data? So you need to find out what? What do you need to find out? So you need to find out the corresponding normalized tau for this data point, right? So you need to find out the data point is 3.85, right? Minus what is the mean, which is 3.957, right? 3.957 over the standard deviation, which is 0.053. So this is, you need to look at the absolute value. Okay. This one gives you 2.02, which is bigger than 1.8. Right? Yeah. So if you want to see what's going on here, basically you can draw a normal distributed curve, right? So this is the range 1.8, which is minus 1.8, right? If the data point is within this range, right, you cannot reject. Right? If it's outside, yeah, right? So your data point now is somewhere here, right? Right. This value actually is a minus, right? Like you look at the absolute value. So your data point actually is here. So what is your decision? Yeah, right? Yeah. You get the data. Okay, so this is the one. Okay, so the second one, based on your decision, find the best estimate for D and calculate the total uncertainties in D, right? Including the contribution from both random and the resolution. So you see, for this type of question, right? If let's say you make a mistake in part A, right? So you say, I cannot reject the data, for example, right? So let's say from part A, right? Your decision is I cannot reject the data. Then you look at the part B, right? Then you know something is wrong, right? Because part B asks you to recalculate the mean and the standard deviation. Right? So if you don't reject the data, basically your mean and standard deviation are the same. Right? You don't need to recalculate it. Yeah? So that means the answer for part A, right? It has to be, you need to reject the data. Right? You gotta find it. Do you see you see this type of question, right? Actually, the answer is very obvious, right? You need to reject it. So if your for example in the exam, right? This part you say I cannot reject the data, that means something is wrong. Because if you cannot reject the data, then you don't need to recompute the mean and standard deviation. Yeah. So So for the part 2, right? Basically, you need to remove the data point for 3.85, right? You calculate the D, right? So this one, yeah, you need to. I already mentioned many times, right? So you need to be able to use the calculator, right? To calculate what is the mean and what is the standard deviation. The result should come directly from your calculator, right? You should not use the summation, yeah, of all the data points again, right? Because you don't have time. Right? You only have 90 minutes, right? You cannot key your number one by one to a square, to a summation. You don't have time. Right? Okay. Let me go to question 4. Okay. So question 4 is okay. This is a kind of typical question, right? Sometimes we don't know what's going on, right? But the question just gives you one application, right? And tells you, okay. So I have the formula, right? T is the tension, right? T equals H. H is the variable, which is what is the variable? Is what? It's the force, right? H is the force, right? And D is the distance, right? L is the length here, right? So which are all indicated in the graph, right? So basically you have this formula, right? G equals H blah blah something like that. Okay. Now, and E, L, and H, right? You are given the best estimate value and also the uncertainties, right? So you need to estimate the value of T and uncertainties, and its uncertainties. Yeah? So this is a very similar question, right? We have seen many times, right? Except the formulas have been different. I also cannot predict what kind of formula you will see in exam. This is a very typical question for to find out what is the uncertainties in the result, right? Okay. So this kind of questions are usually quite tedious, and also you need to be very, very careful because you need to do a differentiation for all the variables. Yeah. So usually if you make a mistake, either due to the time constraint or due to carelessness. So this type of question actually you need to practice. Yeah. Because the formula can be different. Okay, so let me show you one, right? Question 4. So you have this formula T equals H times 1 plus 16T squared over L squared. Okay, so how do you find out the uncertainties in T? Right? So what is the formula? So I think this kind of formula is given, right? Yeah, it's here. Okay. Yeah, if your basically this is the formula for error propagation, right? So if your x is a function of A, B, C, D, right? So you need to use this formula, right? So likewise for this question, right? So you need to use dt over dh, right? Square, right? Plus dt over de, right? E square plus dt over dl, right? Square, right? Over square root, right? Right? So Now what you need to do is, you need to find out where is this one, and where is this one, and where is this one. Right. That's for answer to this T. So the first one, how do you do a dt over dh? dt over dh is what? This one easy, right? So basically it's a 1 plus 16 e squared over L squared. So we just need to substitute in the number, right? So it's 16 here, 16. So 1 plus 16 times e is 1. Where's the best value for e? 30, right? This is 30 squared over L is what? 250 squared. So this is 1.109. Okay. So the first one is easy. Second one, dt over dt. Yeah. How to do this one? Right? So if you think it's difficult for you, right? This one you need to find out from your either your math or whatever, right? How to do this kind of differentiation. So how to do? So d is inside the square root. Okay. So it will be h, right? So first you need to do for the whole thing, right? Yeah. Right. So it will be half 1 plus 16 e squared over L squared. So now it becomes minus 1 over 2, right? Right? Then you need to do it inside here for 1 plus 16 e, right? So this one gives you 32 e over L squared. Yeah. So if you are not sure what's going on here, right? Like this. So this is a basic differentiation. So again, you substitute in all the numbers. For example, h is 10,000, right? So you substitute in 10,000, right? Times half 1 plus 16 times d squared is 30 squared over 200 d squared, right? To the power of 1 over half 32 times 30 over 250 squared. Right? So this one gives you 69.24.